We're going to work on lessons 19 through 21. You'll need this page. It says problem set 19 on one side, problem set 21 on the other. We're going to work on word problems with fractions, and then we're also going to be adding fractions that have different denominators. So we're going to start the word problems with the fractions that have the same denominator. So you know, if it has the same denominator, all we have to do is add those numerators across the top. And then, if your numerator is more than your denominator, it's larger than your denominator, what kind of fraction is that called? Say it out loud if you remember. Improper. It's an improper fraction, and we have to turn it into where we have a whole number and a fraction. What is that called if you have a whole number and a fraction? A mixed number. Okay, so here's an improper fraction where my numerator is larger than my denominator. Okay, and then I'm going to turn that into a mixed number. So remember, you can do a couple of things. You can divide this. 7 divided by 4. How many times does 4 go into 7? Well, it's 1 time, and there'll be 3 left, right? 7 minus 4 is 3. We can also use the number bonds. Now, I've always done it with the division, but I like the number bonds. They're kind of easier, just an easier way to make a visual picture. So whatever works best for you is what you're going to use. But you're going to look at this and say, how could I make one whole, at least one whole? Well, 1 means that the numerator and denominator are the same number. If the denominator is 4, then to make 1, the numerator has to be 4. So there's 4 fourths. 7 minus 4 is 3. There's 3 fourths left over. So I know that I have 1. And how many left over? 3 fourths. So 7 fourths equals 1 3 fourths. Do you remember all of that? Okay. What is this called? Where the numerator is larger than the denominator. Improper. It's an improper fraction. And then when we have a whole number and a fraction, what is that called? Should be saying it out loud. That's a mixed number. All right, so let's start with the word problems. We're going to do 3 together, and then when you do the independent work, that means the work on your own, then you'll have another 3 to do completely on your own. Okay, so I'm not going to write on the paper. That makes it kind of small, but we're going to talk about it out loud. You're going to answer and hear me. Okay, so we're going to use cubes. The E you don't always use. So for the most part, we're using cubs until we get into some different types of word problems that are a little more intense, might be the right word, but have a little bit more. But we're always going to be using C. That's where you circle the numbers. In this case, the refractions. You underline the question, and you box in the keywords that tell you whether you are adding, subtracting, multiplying, or dividing, and then solve it. Okay? So read number 1. It says, Sue ran 9/10 of a mile on Monday and 7/10 of a mile on Tuesday. How many miles did Sue run in the 2 days? Okay, so you should be looking at this problem. I wouldn't be trying to read it across up here. Read it on your own. So I'm going to write answers next to here. So what numbers are you circling? Should have said 9/10 and 7/10. All right. What are you underlining? Read that question out loud. How many miles did Sue run in the 2 days? You should have that underlined. What are you going to box in? There's a couple of keywords. I want you to pause as you need to and talk about it, and then check with the keywords that I found. All right, I had 2 sets of them. I had the word and, because that tells me that she did both of these. She ran 9/10 and she ran 7/10. And then it says, how many miles did she run in the 2 days? Well, those aren't really key words that tell us add, subtract, multiply, or divide. But if it had said like in both of the days, anything like that, those are obvious keywords. But in the 2 days tells me they want me to tell them how many did she run in those days, okay, in both of them, all right? So we'll, for now, until we get to everything we need with the E, I want you to write the equation, all right? We'll call E, we'll go back from cubs to cubes, okay? We'll call the E the equation. That's what you're going to write down, all right? So what do we need to do if they want to know and in the 2 days? Are we adding, subtracting, multiplying, or dividing? I'm going to add. So write that down on your paper. 9/10 plus 7/10 equals, and then we're going to go ahead and solve it, all right? On the video, we'll only be using number bonds, but you can pause it if you need, or if when you're doing it on your own, you need just a little bit more, then you can take out your fraction strips. Use the page that has all the fraction strips together. You can mark them. You can use beans, markers, anything. Get 9/10 of them, and then get the strips that are cut apart. Put the other 10/10 right there to make another one, and then cover up or mark or however you're going to do it 7 more 10ths, and you'll see visually exactly the mixed number. All right, but for now we're going to do this. It equals 9 plus 7, because these denominators are the same. 9 plus 7 equals, say it out loud, 16/10. I can write it like that. This is how I would do it, and write the number bond here. Remember that if you want to, if there's something here that you already see that makes a whole, you could always do that, especially if, like, let's just say this was 11/10 or something, if it was already an improper fraction. But I would just add it and then do the number bond here. The denominator is 10, so how many does it need to make one whole? 10/10. Write that down. You know that's one whole. And then 16 minus 10 is 6/10. So 16/10, we have to put it in a mixed number. What does that equal? 1 and what? 6/10. Very good. Okay, now we're going to leave them like that for today. Because I want us to be able to get through everything. However, for those of you who are like, I got this, I'm a little bit ahead of you, I've been waiting on you to get that answer, one of the things that I want you to start noticing is when I get an answer, is it in its simplest form? That means, is there an equivalent fraction that I can divide it down into? All right? So if you were just kind of hanging on with everything I said, you were just kind of following me, you're just sort of getting it, you're like, maybe I'm a 1 or a 2, then for a second, take a break. You can hear it, but I don't want you to focus on doing this. But if you're a 3 or a 4, you're thinking, I've got this, I'm going to show you something. Normally, your answers need to always be in the simplest form. So if you're doing like a test, and let's just say this was a multiple choice, and you didn't see this answer, but everything you work out says, hey, that's 1 and 6/10. That's the right answer. Well, look and see, do they give you any answer choices that have equivalent fractions? So 6 and 10, can I reduce that down at all? Is there a number that goes into 6 that's a factor of 6 that's also a factor of 10? One of the easiest is they're both even numbers. So I know for sure 2 goes in there. Well, think about 6. I can do 2 times 3. Can 3 go into 10? Nope. Can 6 go into 10? Nope. So I'm just going to divide both of these by the number I know both of them can go into, or can go into both. 6 divided by 2 is 3, and 10 divided by 2 is 5. So this is an equivalent fraction to 6/10. So I can say in simplest form, the answer is 1 3/5. okay? But 1 6/10 is also correct. And if you are watching going, oh my goodness, I can't do that. I don't know what she just did. Don't even worry about it, okay? This is just if you were waiting on us or you're trying to yell the answer out before everybody else can get it because you've got it and you're waiting. That just gives you one extra thing that you can work on. The rest of us will get there later. We don't even care. All right? So let's look at number 2. I'm going to read it to you. I want you to do cubes as we do it. So circle the answer, or circle the number, underline the questions, box any clue words in that tell you whether you add, subtract, multiply, or divide, write the equation, and solve it. All right? So Mr. Salazar cut his son's birthday cake into 8 equal pieces. Mr. Salazar, Mrs. Salazar, and the birthday boy each ate 1 piece of cake. What fraction of cake was left? Now you've got to use some good thinking there. What numbers did they give you? 8 and 1. So there's 8 pieces. Did they eat 1 piece? No. You would need to circle Mr. Salazar, Mrs. Salazar, birthday boy, and the number 1. I would maybe, you can circle those or check them, anything. I would write the new answer down. How many pieces did they eat? They ate 3 pieces, right? So for right now, I have 8 and 3. But I want to know, I'm going to go on to the U, to underlining it. And then let's try to figure out what are those numbers that they're actually saying. So underline the question and read it out loud. What fraction of the cake was left? Okay, so you're going to underline that. What are keywords? What are the keywords that tell you whether you add or subtract, multiply or divide? One is we don't know how to multiply or divide fractions. We know how to multiply, like to say 3 times 1/3. Or 3 times, let me give you a different one. 3 times 1/8 equals 3/8. 1/8 plus 1/8 plus 1/8. But we haven't really done multiply or dividing. So we know it'll be add or subtract, right? They ate it, right? They each ate. So I'm going to box in the word ate. I know that that means they what? They need to subtract, okay? Now let's look at these. Am I just going to subtract 8 minus 3? No. There were 8 equal pieces. So how many pieces were there? 8 out of 8. That's it. They had 1 whole cake. They had 8 pieces. Right? So go back in, write that in somewhere and circle your number. How many pieces did they eat? 3 out of 8. These are now my numbers. I have to think, I have to use my brain and really see, what are they asking me? Sometimes, a lot of times, the question or the numbers that I need, everything is not just going to be there simple and easy. You've got to use your brain to kind of think through it and see what they're asking you. All right? So write the equation. Now what do I have to do? I have my numbers. I know I have to subtract. 8/8 minus 3/8 equals 5/8. All right? And because my numerator is smaller than my denominator, it's not improper. All right, so I want you to try number 3 on your own. All right? Do the very best you can. Get as far as you can with circling the numbers, underlining the question, boxing in any keywords, and writing an equation. Go ahead and solve it if you can. And then I just want you to take probably 2 minutes, and then I want you to play the video again and follow through. So if you didn't get to finish it, then you'll finish it as you do it with us on the video. All right. I'm going to show you answers up until the equation, then we'll have to add some things. It says she spent 4/7 of her money, so that was the number you should circle, and she saved the rest. Here's the question. What fraction of her money did Maria save? You should underline that. Here's some key words. She spent some money, and how much did she save? Okay, so she spent, I know that she's going to what? I need to what? Add or subtract? Subtract. If I spend it, I give it away. Well, how much did she save? That's the same as saying, how much does she have left? So I'm going to subtract. But the fact is, I only have one number. I know she spent 4 sevenths. Well, how many does she have? What's one whole? 7 sevenths, right? That's all of it. She had, at some point, she had 7 sevenths. So you could think of it like $7. She had $7 out of $7. And she spent 4 of those $7. So my equation should be, oops, I wrote 7 minus 7. 7 sevenths minus 4 sevenths. And that answer is 3 sevenths. All right? You'll practice that more independently later today. And I just want you to practice your very best. Try to figure it out on your own. Try to figure out what they're doing, what they're asking you to do in the questions. And don't get frustrated if it doesn't just say she has $2, she spent $1, how much is left? Okay, those are second grade questions. Beginning of third grade questions. Now we're asking fourth grade questions and getting into fifth grade questions where we say, we're going to ask it a different way. Think a different way. Okay, so we'll just keep working, but you need to think through those. All right, so now we're going to work on the other side, the problem set 21. All right, so we're going to work through these. You're going to practice each one. All right, we're going to practice, and then you're going to practice some on your own, but you're really going to have about 2 days to work on it, and I really want you to just try it. Keep trying, keep trying, keep trying. You're going to need those fraction strips and that page of fraction strips that are all together. All right, so when you look at this, it talks about drawing a tape diagram. And then on number 2, it says draw a line to model the addition. Those are strategies and we can use them. But when you are drawing out the fractions, I think that it gets really messy because you have to draw this box and then you have to try to break it into pieces. Okay, now I'm going to break it into, like 4s is semi-easy. So let's try 5, 6, 7. Okay, there I broke it into 7s. Well, yeah, I better do 6s. Okay, I broke it into 6s. Now I have to remember that here's 1 6, 1 6, 1 6. All of them are 1 6. Here's up to 3 6, right? So this is 3 6 right here. Then I have to go back and I have to draw again to make them into 12s. And to see, well, now how many 12s does that equal? It becomes a lot of mess. Where we already have these printed out and you can match them up. That's what I would do. I would not draw that tape diagram out, okay? If you're doing some type of test and you don't have these, you could try to draw it out, but I would take my time to make it neat, okay? I wouldn't draw it. I would think of the other strategy that I'll show you. So we're going to use the strips, and then we're going to also use the actual way you do it. All right, so I'm going to write it on here. We're on A. It says 3/4 plus 1/2. Okay, so what I want you to do is I want you to get the fourths out. Find those. Yours probably are in a better order than mine are. Well, not only they're in better order, I can't find mine. I was going to tell you can go backwards there. I found the fourths. If I wanted, I could use the halves. Either one. I'm finding the fourths, and I'm going to hold them up to the halves. Okay? So this will be on your desk. So it'll be easier. You're looking at it like this. All right? 3/4 plus 1/2. Well, the fact is, the denominators have to be the same before you can adequately add them. All right? So I have 3/4 right here. I have 1, 2, 3. Okay. Now I have 1/2. Well, I have to figure out how many fourths is this 1/2. look at it closely on yours. There's 2. I could split this right here. And now I have another 1/4 and another 1/4. So what does that equal? Count them up. 1, 2, 3, 4, 5. That equals 5/4. Okay? So I want you to write that underneath, or actually write it right next to it. Where they have it printed, right next to it. But don't use up all that space underneath, because we'll use that as I show you the next part, the way to do it without the fraction strips. Use your number bond. How many makes 1 whole? Look at your denominator. 4 out of 4. That's 1. And how many would be left? 5 minus 4 is 1. So that equals 1 and 1/4. 3/4 plus 1/2 is 1 and 1/4. Okay? All right. So we can see that. All right? Now, I'm going to erase. You already have it written down that it's 1 and 1/4. Okay? You're going to use the space underneath. Now, you're going to rewrite neatly, but what I want you to do is make sure that you leave a good amount of space. So you have some space before and you have some space after. Write that down. Okay? This is how you figure it out just on paper when you have to calculate it and you don't have the visual models. All right? You have to have the same denominator. So this is where we're using the multiples. What this is a factor of, okay? So you're thinking, what can this make? What can 2 make? What can 4 make? And you are finding, we call it the least common multiple. That means the smallest number that each of these can make, okay? So the easiest way always to start is look and say, can the smaller denominator make the bigger denominator? Can you multiply 2 by something to get 4? Yes. 2 times 2 is 4. So this fraction doesn't have to change because 4 is going to be our denominator. But we have to make an equivalent fraction over here. So you said 2 times 2 is 4. So we're going to multiply the numerator and denominator by 2. 2 times 2 is 4. 1 times 2 is 2. Okay? Now, underneath, I want you to write it neatly. We have 3/4 plus, what's our new fraction? 2/4. It's still the same fraction as 1/2. It's just an equivalent one. It equals the same amount. Okay, what is 3/4? Now we have the same denominators. What does 3 plus 2 equal? 5/4. Do the number bond. How many makes 1? 4/4. And how many is left over? 5 minus 4 is 1/4. What's going to be my mixed number? 1 and 1/4. Okay? So we did the visual model, and now we're doing it where we have to make the equivalent fractions. All right? And so let's try letter B. When we do the visual model, we're writing it right next to where it's written. And then when we do it where we have to find equivalent fractions, we'll write it down underneath. All right? So you have 2/3 plus 3/6. So I want you to find the fraction strip of the 6s. All right. Did you find your strip with the 6 on it? With the TH on there? 6. All right. We're going to hold that up. We have the 6th, and then we also, the other one is 2/3. Okay? So mark it off, whether you're using a marker or a bean, something to show it. Mark off 3/6. 1, 2, 3. Okay? Plus 2/3. Okay? So we need this 1/3 and this 1/3. But they have to have the same denominator. So we have to split them. These are 6 right here. And you can see how many 6 equal 1/3. 2. So we're just going to split it. Where you see the line in between the 6, draw one up there. Now, if yours isn't laminated, I don't think you guys have a laminated one. You can, I don't know, either draw on that paper, and then I'll have to make more copies. That won't be the biggest deal in the world. Or just know for yourself, okay, we have a line right there. Like you could put a pencil there. Okay. So we have these 3 6s, and now we have to add all these 6 that make 2/3. So count them up. Ready? 1, 2, 3. Now here. 4, 5, 6, 7. How many 6 do we have? 7 6. Write that down. Quickly, I want you to do the number bond and turn it into a mixed fraction and then check mine. Very quickly, like 30 seconds. All right, you should have said 6 6 makes 1. 7 minus 6 is 1 6 left over. So the mixed number is 1 and 1 6. All right, now we're going to do them underneath. Okay, so in that space, you're going to write 2/3 plus 3 6. And remember, we need the same denominator. All right, so it never can go down to the smaller one. But like we need to leave that. The smaller one is going to go larger. All right, so we need a number that each of these numbers can make. So a number that 3 can make when I count by 3s, and a number that 6 can make when I count by 6s. Has to be the same. The easiest trick first is to look. Does the smaller number go into the larger number? The answer is yes. So I know because 3 times 2 is 6, I can use 6. So what do I have to do to 3 to get to 6? Multiply by 2. Because it was written first, I'm just going to write it over here. If I try to write in here, I'm going to have a bunch of mess. So I'm writing it over here. Okay? I'm going backwards. 2 times 2 is 4. And 3 times 2 is 6. My new fraction is 4 6. And you saw that on here because we split them apart. My 2/3 equaled 1, 2, 3, 4, 6. All right? So now in my space, I would rewrite that. 4 6 plus 3 6 equals, same denominator. You know how to do this. 4 plus 3 is 7. 7 6. Okay? And then that same number bond up there, they need 6 6 to make 1. 7 minus 6 is 1. So I have 1 whole and 1 6 left over. They're the same answer. All right? So I want you to pause probably 1 minute and ask any questions that you have and give a rating. A rating being 1 is, I can only do this if I'm walking through it with somebody. 2 is, I think I can try this. I might have to ask you a question or 2. Okay? 3 is, I'm getting what we're doing and I think I can do this. Probably no help. All right? So pause to do that and then come back and hear the next part. All right, I hope most of you were at about a 2. If you're at a 1, that's okay. We're going to try some. You already showed the teacher in there that you are at a 1. So the teacher is really going to try to pay attention and be close to where you're at. Or maybe all the ones kind of sit over in the same area. That way, you're probably asking the same questions. You can get started and say, wait, what's this? And that teacher will say, remember this part. All right, so what I want you to do is letter C on your own. All right, do that. And then if you're waiting for everybody else, you can go on trying to do D and then number 2, A and B. Don't worry about that they're telling you draw a tape diagram or draw a line. Use your visual model if you need it. And if you think, I've got this, I can just do the algorithm. That means the formula that I've showed you, how we do it, the steps, then you just do that. All right. And then you'll unpause the video and we'll check letter C, which is this one, 5 6 plus 1/3. I am going to show you only the algorithm, only using it. I'm not going to show you the visual model every time. So you will have to show that with each other. Like in the classroom, you'll have to do that either with a partner or with the teacher in there. So when you unpause it, I'll show you the answer for this one, and then we'll go through a couple more before you start working on your own. All right, you had 5/6 plus 1/3. You can look and say, hey, 3 can make 6. 3 times 2 equals 6. So I'm going to make an equivalent fraction with that. Multiply both my numerator and denominator by 2. 1 times 2 is 2. 3 times 2 is 6. These two numbers, 1/3 and 2/6, are equivalent fractions. So now I'm adding 5/6 plus 2/6 equals 7/6. Use my number bond. That makes 1 with 1/6 left over. All right? Now, I want you to do letter D. If you haven't done that already, pause the video, do it. Use the visual if you have to. Otherwise, just try to do the steps and then check back with the answer. All right, 4/5 plus 7/10. I can see 5 goes into 10, right? All I had to do was multiply it by 2. I ran out of room, so I kind of have to make almost chicken scratch. Just make sure that you can see what you're doing. 4 times 2 is 8. 5 times 2 is 10. So my new equivalent fraction is 8/10. So that these two have the same denominator. 8/10 plus 7/10 equals 15/10. 10/10 make a full 1. 15 minus 10 is 5, so there's 5/10 left over. Okay? And if you went on and tried to reduce that or simplify it, you would see that this is 1 and 1/2. Either answer is correct. All right? I want you to do the last two on your own. Get help as you need. Get those checked or checked with people right around you if you are waiting on other people. To finish, push play, and let's make this not blurry. Push play, and let's check those last two. All right, let's look at number 2A. You had 1/2 plus 3/4. I can see that 2 goes into 4. You have to multiply it by 2. So I multiply by 2 over 2. 1 times 2 is 2. 2 times 2 is 4. So my new fraction, my equivalent fraction with the same denominator, is 2/4 plus 3/4. Well, 2 plus 3 equals 5, so that's 5/4. Make my number bond. 4/4 makes a full 1, and 5 minus 4 is 1. There's 1/4 left over. So the original question, 1/2 plus 3/4 equals 1 and 1/4. Okay? Let's look at the last one on there, letter B. All right, letter B, it was 1/2 plus 6/8. I can see that 2 goes into 8. 2 times 4 is 8. So I'm going to multiply both